Alright, welcome back. So, this is CodeForces 1270i, where you're given a toroidal grid whose dimensions are a power of 2, at most 512. And then you're given a figure of odd. A figure is like, I don't know. Wait. Sorry. What the heck? How zoomed out am I? Oh my lord. I'm like 13%. Okay, let's try that again. And you have like a figure who the number of cells in the figure for which is assumed to be odd. And I can go to some place in the grid and like XOR all the cells in those positions by some fixed constant, not fixed constant, by some constant of my choice. So maybe if I show the example, it looks like, so here, for example, here's a 4x4 grid, there were some numbers inside it, and if my shape was, this long L or something, then I can XOR all of these by 2, and then XOR all of these by 4, and then XOR all of them by 1. So already there's kind of like multiple copies of the problem, because the different bits don't talk to each other. So the constraint on the input at 0 aij is less than 2 to the 60 means that it's really, you can view the yeah, you can view the numbers as elements of f60 or f2 to the 60th power. We're not doing subtraction here. And so it's real interesting because it's not like you can take the 60 subproblems and solve them quite independently, because you want to reuse copies of the... What am I trying to say? If you're only interested in whether or not it's possible to do it at all, you can actually treat it, you can treat the 60 coordinates independently, because all you do is, well, you commit to only XORing by powers of 2. But if you're interested in the minimum number of operations, then well, I feel like this is going to be some linear algebra stuff. So here's a way you can describe the problem. So fix an index I from 0 to 60, and then if I look at what does the grid look like with just zeros and ones. So if I look at only the ith position, it's now a binary grid. And the question is, can you write this grid as the sum of copies of f? And if you can do so, well, the copies of f, the figure f, there's also, how many places can I put f in? Wait a minute, really? So there's 2 to the n squared places to put f. And there's 2 to the n squared possible little grids. So, here's a question. Is it true that if f is odd, if f odd, does every set of placements is it a bijection to the set of possible grids? Yeah, so I was worried about the same thing, but if it turns out, and like f is odd, I'm assuming for a reason, and I hope this is the reason, because if it turns out that we have a bijection where then what that means is that given a 0-1 grid, well, first of all, that is always possible, and second of all, there's a unique way to do it. And if that's the case, then what the problem will boil down to is for each of the subgrids that you get, you compute the unique way to place copies of f to clear the grid. And then what you do is you run through all 60 indices and say, okay, which positions appeared at least once? And then the answer will literally be the number of positions that appeared at least once. So, is it true that there's a unique way to do it? I think it probably is. Because otherwise it feels like it should be, because I feel like that's probably why f is odd. Like if f is even, no way it's true. But if f is specifically given to be odd, I feel like it ought to be true. So now I have to think about... So if it wasn't the case, then what that means is that there's some minimal set. There's like something in the kernel. So there's a way to place copies of f such that the sum of these copies of f is the all-zero grid. But f is odd, and so if I just do a naive sum, we were also given that the dimensions of the grid are a power of 2. So what you need is like the number of copies of f that you needed to place. No, that's not great. But okay, like, also, I feel like the claim should just be true. Here's okay, we're gonna use generating functions. Like in f2 of x join y, I have this f, which is the sum of like an odd number of things of the form x to the a y, y to the bi, and then the assertion is that everything mod 2, like f times some choice of placements. I don't know. I don't know what variables to call these. Should be equal to like 1 plus x. And n again is given to be a power of 2. So I have like something like this mod 2. Okay, but what happens if I plug in... Gosh, the problem is everything's mod 2. I was about to like plug in everything equal to 1, but that's not quite what I want. Oh, okay, but okay. Here's the thing. Okay, like if I'm working modulo 2, there's a much easier way to write this. I can write this as 1 plus x to the n. Or sorry, no, 1 plus x to the. This is true, right? When I'm working modulo. Sorry, yeah, sorry, let's just n minus 1. Alright, it's n minus 1. If I'm working modulo 2, this is true. Because n is specifically given to be a power of 2. Aren't you just done here? Why am I done? The factorization should be unique. I see. But the point is that if you actually plug in x and y is 1, because f is odd, this number is odd. So this thing has no factors of 1 plus x and 1 plus y in it. So, yeah. Alright. Well, that's a very nice math result. Yeah. I mean, the point is this thing is not divisible by 1 plus x. Just because f is odd. Or, it's not divisible by... Oh, actually, I have to be a little careful. It's not divisible by both... it's not divisible by 1 plus x, 1 plus y. No, it's not divisible by 1 plus x. If it's divisible by 1 plus x, the number of cells in f is odd. That is actually also true, right? Yeah, but the problem is the two... It's not that many variables, right? No. Okay, the grid size is up to 9. Not grid size. The power in the grid size. So it's like you have 60... I need to solve 60 subtasks. Each subtask is a 2 to the k by 2 to the k grid, where k is at most 9. There's a given shape f, and there's some like 1s and 0s. Okay. The 60 subtasks they have the same f. So what's happening is I want to, you're basically solving some linear algebra thing. Oh god. I might not be able to use Python. This is not going to be fast. I agree if you have a basis vector. Okay, I have to think this through. So the number of variables is up to 512 squared, which is like 20. 262. Oh god, I'm getting old. I can't even. I don't even remember. One four four. There was a time when I could compute powers of 2. Like I could square numbers much faster than I just did now. So it's a linear equation with 260,000 variables. So I can't find basis. I don't think I will be able to find basis vectors quickly enough. But yeah, I think what happens is... Oh lord. How expensive is it to invert a matrix? That sounds pretty expensive. And then yeah, the grid is too big. It won't work to just... It's not like, oh, is it not a UFD when you quotient by... Oh, that's true. It's not quite a UFD. Ah, right, because I'm taking mod. Oh, but this is... Yeah, no, Dolphin's right. It's not an integral domain. So it doesn't even make sense to talk about it like a UFT. But I feel like something... Can I say like, like 1 plus x to the n minus... Like if I, like, here's the capital F function and then times whatever the product thing is. In just F2 adjoin xy. So without modding out... I think this is true, right? Because, because it also divides x to the n. If I just do that, is it good? Yeah, so the fact that this divides this thing means that I can do the modding by x to the n minus 1, not at the level of the field, but at the level of the divisibility. Oh, sorry, yeah, my head's blocking that. We don't really need the problem statement anymore, I think. Yeah, so I think the idea is that you can do this argument at this level of divisibility, where, if f is a generating function for this and g is also, then this statement should be true. Because you can take modulo, you can take modulo x to the n minus 1. So that will wrap everything up there. And then... heck, we'll even just set y equals 1, alright? like take this equation, set y equals 1. Okay, take this relation, set y. Shit, y is a power of 2. Oh, I don't want to do that. Shiba. Okay, well, sorry, what am I trying to say? It's like f times g mod 2, if with everything taken mod 2, it's equal to 1 plus x to the n minus 1 times 1 plus y to the n minus 1 plus 1 plus x to the n times some garbage term we don't care about, plus 1 plus y to the n times some garbage polynomial we don't care about. All of this is in f2 adjoint xy. And now, if I just plug in x equals y equals... Yeah, I agree the claim has to be true for the problem to be doable in CodeForces. Like, if this is not doable, we're in a world of trouble. But... Yeah, I guess if I plug in x equals y equals 1... Or even like x equals 1 and y equals... If I plug in x equals y equals... Yeah, it's just 1. Like, we get that this number is divisible by 2 to the n. But this one is odd. Maybe the problem is that 2 to the n isn't enough stuff. But I feel like now I'm confused about how many powers of 2 I get. Oh, hang on. Sorry, what am I smoking? Why did I write this thing? This is not the right thing to write down, right? This is if I want to get the grid of all ones. That's not what I want. Like this should just be 0, like on the... Oh god, hang on. Yeah, sorry. I'm making up garbage. This is not correct. This is not correct. This term shouldn't be there. I mean, it's like it lies. I want to have it lie in the ideal generated by this stupid thing. Okay, that's not good. Hey, here's a question. How do you do the 1D version of this problem? Like if I had a row instead of a domino. Okay. Wow, we asked the exact same question at the same time. It should also. So here's the interesting thing. Like even though the constraint is that f is odd, I bet you can weaken the constraint to just any row or column of f has an odd number of cells. So let's talk about the because the other thing is we do like even if I can prove uniqueness, it's no good if I for the CodeForces problem. It's no good if I prove only uniqueness and then don't have a way to actually construct like a thing. So I guess we can put on like we can pretend to think a little. Oh, that's annoying actually. But like if okay, I feel like I need to know how to do like if I just have a single row and then I have like a shape, quote unquote shape f that consists of some number of cells. Like if I can't solve this for the 1D case, there's no way I'm going to be able to do the 2D case anyways. You claim it's just induction. Why? Yeah, so let's do this 1D case where I have like, in fact, let's just say I want, let's call it, let's do the generating functions properly. I want to show that 1 plus x cubed times something is going to be in modulo. Alright, I'm going to be consistent and use capital G. One. Or I guess in this case it's like 1 plus x squared plus x to the 6. Okay, actually I should just do 1. Let's keep the symbol first. Okay, so I see why I'm being nudged towards the inverse. Mod x to the 8. So in other words, I want 1 plus x minus 1 to the 8. Times some quotient, I guess. Mod 2. Is this gonna be a sum like cancel kind of thing? If I lift? Hang on. FFT. Okay, I have to remember how this works. What is FFT? Oh wow. Assume the number of coefficients is the power of 2. That's very convenient. Uh, I see. Dun, da, da, dun, da, da, dun, da, da. Okay, what is this trying to do? They're trying to... Yeah, okay, blah, 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 blah. Oh, Lord. You know, one day I should actually learn this stuff. Thank you, Unreal Life, for the follow. Okay, what happens if I replace x with y plus 1, then what I'm hoping for is this thing to have some inverse. And I have a basically working hypothesis. Basically, the hypothesis is that if this has a constant term, this has like some, I mean, I don't really care what the coefficients are, but I guess they happen to be, oh, this is just 1 plus y cubed? No, whatever. Yeah, that is, that better be true. So even modulo a composite modulus, inverses work the way you want them to. Where if you're relatively prime to the... Yeah, you have an inverse as long as you're relatively prime. And then, okay, that probably tells me how to do the... Yeah, so... Okay. In the general 2D situation, if I had f of xy, what I'm hoping for is something such that this is in the ideal generated by x minus 1 to the n times... And even though this is not like a unique factorization domain on the elements, this is still like a perfectly fine ideal. Everything here is in F2, and so as long as F is not in the radical of this ideal, I think is the condition I want. As long as F is not in the radical of the ideal, I'm okay. But the radical of the ideal is actually just x minus 1, y minus 1, I think. And F isn't. So that's the math proof that there's an inverse. You don't need FFT? Oh, okay. Then I will not read about this thing. So this is fine, but it sort of begs the question, like, how do you actually compute the inverse then? Because that's kind of what I would like to do. So in the 1D case, I guess, like, it does look like it is a Hensel type thing, where if I want to compute the inverse of a certain polynomial modulo x minus 1 to the 8, well, you compute the inverse mod x minus 1 first, or something like this. And then you use Hensel repeatedly to... Oh lord. I don't see how you... I feel like my intuition for like the 2D case is really bad because the ideal here is not principal. Can you just do something similar? I don't know how you do Hensel on non-principal ideals, unfortunately. Oh, right, the problem statement the problem statement is this. XOR on figures. So, square repeatedly was suggested. So the claim is that if I have an inverse mod y and I square it a bunch of times, I'll get an inverse mod y to the 8. What? The inverse is f to the 2 to the chi minus 1. Oh, well played. So, okay. Yeah, that was... Oh, well played. Okay. K is small, so this might work. I think the problem, even a single multiplication. So if f is a generating function for a 512 by 512 grid, I square it. F is sparse. Oh shit! F is sparse. Oh freaking heck! F is sparse. No, no. This is what I get for not reading this statement. Okay. Anyways, okay. Okay, F is sparse. Oh, that's important. Okay. I wasn't paying attention. I was just like, F could be as big. Oh god, it's up to 99. Okay. Okay, so you guys actually just want to use the full matrix, the full, because I'm still, F is sparse. That's fine. If we're gonna do like some number of multiplications. we do some number of multiplication, like on the order of, if we want to do inversion, like if it's a, well, it's going to do like 20 things. That's fine. How fast does sparse matrix multiplication grow? I have a sparse matrix. Like, so suppose I have like a, oh god, but it's still. It. 99 to the 20 is still pretty. Am I not thinking about this the right way? If I multiply two sparse matrices, the number of non-zero entries is like the up to the product of the previous things or something? Oh god. I have this problem where like even, okay, let's suppose we even have the inverse. Then I need to like apply this inverse. I guess that's okay. Like if I do one like 262 like 200,000, no. Oh, sorry. I keep mixing it up in my head. The grid is up to 512. So there's at most 200,000 entries. And if I have a reasonably sparse thing, does the runtime? Jesus. I don't think it's worth factoring 511, because 511 is 7 times 73, so it's not great. Where did my tablet? Oh, here. Okay, so what's the plan? So we have a generating function f that's given to us. It's sparse in the sense there's up to 99 cells in it. X to the AI, y to the bi. We're going to compute f of x to the y to the 511. And we can do this by in like 18 multiplications-ish. Once we have that, we have an inverse modulo the things we care about. So then for all like indices 1 through 60, if I look at the grid GI, so the GI is also kind of given to us. I shouldn't use I twice. We'll call this like L or something. And then what we do is we look at GL, multiply. So the problem with GL is that GL can have up to 500,000 things. I guess that's okay. If we believe F is kind of sparse, we compute this thing, and then we look at how many non-zero entries how many non-zero coefficients it has. Actually, we write down what the non-zero coefficients are, period. And then remove them, like make a list. And then the answer will be how many things showed up as non-zero coefficients in at least one of the GL times F to the 511 products. Yeah, 511, yeah. You not need fast Fourier transformation? Like, I feel like this is like this is what FFT was built for, right? Like, you can multiply polynomials really quickly. Right, like I guess the whole point of this is that it lets me multiply two polynomials in like rapidly, right? Well, okay, so I guess it's it's multiplication of polynomials in F2, which, oh lord, we haven't used the fact that F is sparse yet. I thought the sparse condition was just telling us that computing F to the 511 was not that bad because F is sparse. Like, I guess, well, if F is sparse, are like the powers of F that's sparse either? I'm actually just not sure because I haven't done something this applied to them. F to the, okay, alright. Yeah, okay, so it does go, okay. So that means I might need something else. I might need another idea before I can pull this off. F511. The square of a sparse thing is sparse. Right, but right, so I can compute all the square. I can compute all the squares. Is it like when I multiply the 9 things? Like I'm not literally going to take a 511th power. Like I agree, I know we're going to use like repeated square thing. But I feel like I'm still worried that if I take like these, I guess 18 is just not that, I don't know. Oh sh. Okay. Oh, when you said sparse, you meant literally the number of coefficients is like the same thing. I see. Okay. Yeah. I see. Okay. So I agree. You don't want to compute 511. But I guess like from the math point of view, the point is that this is fxy, fx squared, y squared, up to like fx to the 256, y to the 256. Okay, but like, Like, for example, this thing is very easy to compute, right? Because, like, almost all the coefficients are, if you're taking mod x to the 512 minus 1, this is, like, about as... Like, there's, like, at most 4 coefficients. Don't you just do it now? I'm still like kind of worried that this, even if you, so I don't know, this step still seems pretty, like, even if I gave you f to the 511 on a silver platter, like literally just told you what it is, you want to do it that way? Is that faster? I'm not sure. Is that faster? It is a lot faster. Let me convince myself. Okay. Really? I guess so. The point is that each... Okay, so the problem is that, yeah, if you try to compute this thing directly... Well, even if you have the value of it, you actually don't want to use it. Like, you would prefer to use the factored value, because this thing could have a lot... This thing probably has a lot of entries, and these things are all really, really sparse. Each of these has almost 100, but each of these could have, like... Well, this whole thing can have up to, like, 200,000, and then this thing, of course, is up to 200,000. So you really don't want to... Okay. Now, how... I have to implement this, huh? Yeah, I see. So in general, if you have a bunch of sparse matrices and you want G times the product of them, you want to keep throwing the sparse ones at G instead of multiplying. Okay. Yeah, that feels... Okay. It feels a little sad to me because it's like, oh, you know, you would prefer to pre-compute f to the 511 in some sense, but it's not possible if you do it that way. Okay. Alright. Fine. No, this problem's good. I mean, I'm assuming that these ideas that, like, the inverse is just a large power and also factors. This can't be the first problem that uses these ideas, right? Like, these have to be things that the top IOI people know. Is that true? Did the I'm assuming the IOI kids have just seen, like, this idea before, because it seems like it's pretty useful. I might be wrong about that. That's just kind of my guess. Characteristic 2. Yeah, when you're... Yeah, in math, I'm just like... Yeah, just assume the characteristic is not 2 or 3. I don't think... Really? Okay. I do know that Fourier transform is actually banned on IOI. I remember hearing that at some point. Anyways, okay, well... Yeah, this is my first time seeing characteristic 2 used this way, so it is pretty cool. But there's others. I just feel like, I don't know. Seems like this can't be the first time this idea has been used. Okay. Anyways, how do I implement this? NumPy? Does CodeForces let me use NumPy? I literally don't know, because I don't think I've done linear algebra on, like, a computing problem before. Just homebrew your matrix. I don't know how I feel about that. Yeah, I should just do it myself. Okay, I can do it myself. That's fine. It's not quite matrix multiplication, but if you guys are telling me that I can implement this without importing any libraries, then I believe you, and then I'll try to do it. If there's a library I should be using, I would like to know. If I don't need a library, I'm happy to do it by hand, because I know what I'm supposed to do. But no libraries required. Okay. Alright, we'll do it. Yeah, unfortunately this is going to actually require some implementation. It's not like the that's not what I meant to do. So now I have to decide, I haven't used C++ in so long because there's been some coding problems on stream recently, but they've all been problems for which you could do it in Python, and like Python is sort of my native language, so I keep doing that. If I should be using C++, I don't know. .512 by .512 is fine. That part's I'm not worried about. I'm worried more about just Python is not a very fast language. I'm gonna try to submit a working solution. Alright, we'll use C++. Shit, that means I need to copy my ILI template. Yeah, I believe that it would be possible, but I am also a little... Okay, int main. Okay, what's the input specification? So... Yeah, I agree. We want to use bit arrays. Oh god. All right. So int k. I don't even is this how I store an integer in k? I haven't used this in so long. I don't remember how to read input. For int I equals 0, I less than. How do you exponentiate in C++? I don't even know that. Is it like 2 to the k? Is it No. What? 1 less what? Is there not a PAL function in C++ or something? At least? I have to write that? I mean, okay, whatever. It's, alright, how do I read? Oh god, this is gonna be... This is gonna be rough. Okay, so first, what I need is the 60 things that... Okay, so... in 64... we'll call it grid. Is this how you make her... You can tell how often I use C++. Okay, so I read the grid. Also, now I need to read... Okay, so T is... You know what? No, we're gonna do this. We're gonna do this properly. Bool. And then, so... Okay, how do I get the... Okay, we'll let E be the entry. So for in L equals 0, L less than 60, plus L, grid I, J, L is... Okay, so how do I do integer... Oh, shit, this would be a long integer. How do I read the Lth bit of an integer? Bool still uses 4 bytes? It takes 4 bytes to store a boolean? Are you serious? It should... Okay. If this is less efficient, I won't do it. I'm just surprised. But okay, fine. Never mind. I want an array of ordered pairs. Oh, whatever, we'll just do it this way. Okay, great. Lovely. We finished reading the input. Oh, are you serious? Python actually just works? God. Alright. Maybe I should have done that. Okay, whatever. We're here, so I'm just gonna finish this. I need the C++ practice anyways. Alright, so... Alright, what did we agree the algorithm was? So for every L, What do I do? Okay, so we're gonna start with the, okay, so for int l equals 0, l less than 60 plus plus l, we're gonna start with the, we're gonna start by initializing the grid based on something, whatever. We'll, so what I need to do is I first need to read it, and then I need a procedure that lets me multiply, do the multiplication. Okay, so for int I equals 0, just an n. So we'll start by initializing, and then man, I actually type plus plus I because I'm so used to asymptote where you're not allowed to use I plus plus for unknown reasons. So I have this problem where I keep. Oh, am I missing an idea? Oh, the 60 I see. The 60 actually matters, and I shouldn't be repeating this. I should just be XORing the numbers. I see. Okay. Alright, that's fine. Alright. Oh, okay. So we're gonna make a thing called next grid, and then we will just, okay. Actually, wait. I need to think this through again. So I have the grid, and then for each thing from 1 to 9. Okay, so I'm going to take grid as given, and then next grid, we'll use e for exponent, and then for any y less than t plus plus I. Okay, so what I need to do is wait, how do you do multiplication? 2e, 2e. Did I ever define n? Yeah, I did. Oh, no. Okay, I guess that's not how... We'll just call it C, whatever. I was hoping for a moment you could start a variable name with the letter. Okay, so I want to XOR this. Is XOR like the... What is XOR in C++? Is it the caret or is that AND? Is it like... It should still... Okay, cool. Shows you how I'm going to use this. So grid... What am I typing? So... Okay, hang on. So for every cell in the grid... For every... the indices are so bad. We're gonna use M for... Okay, so it's like I, J, and then like the offset. Okay, so I think this is supposed to be multiplication by... Okay, multiply... So multiply by f of x, y, polygen func. And then copy the result to the old grid. Back into the old grid. Okay, so this is the multiplication. And then I'm looking for all the things which are not 0. I think there's no chance this works, right? Like I'm just like, how do you type it? Okay. All right, let's learn how to debug this. Yep. Okay. What is pop count? What is pop? What is this pop count you speak of? Pop count? Okay, well, okay, let me first see what the heck is going on. So I have this debug function. I'm trying to remember how it works. Wait. How do I already forgot how I... Is this not how I do the debug thing? What? Wait. Okay, my template is supposed to have something that lets me print debug statements, but for some reason I can't figure out how to use it, because I haven't used this in too long. Okay, wait. No, it's working. That just means... How did this loop... Oh. Okay, well that's not good. What? Why is every entry in the grid 0? Wait, I disagree that it should be based on S2 or pop count or whatever. Like, hang on. Oh wait, actually no, you might be right. Hang on. Okay, but first of all, this shouldn't be giving me 0 everywhere. So something's wrong with that. Grid, all the entries of the grid are 0. C in, grid I plus C. N equals 4. Yes, I agree. So, okay, so N is there, yeah. Why? How is it that everything in the grid ended up turning into 0? It's not pop count, yeah. It should be. No, actually, I feel like non-zero is correct. Like, this is counting the number of places where I need to apply. Okay, wait, actually, no. No, yeah, no, I feel like this actually is not. It is count plus plus, right? Is next grid... Oh, do I need to actually set everything to 0? Oh, Lord. Oh, I need to reset... Oh. That seems pretty important. Okay, now it says 9 instead of 3. So we're improving. Yeah, I agree. This should be reset. Do I need to reset everything at the start? I mean, there's no reason not to do it. I don't understand how initialization works. Now it says what? Oh wait, no. Hang on. Let's try that again. You can tell that I do not normally do programming contests. Oh my god. How do you read input? Okay, so now it still says 9. What did I mess up this time? Okay, well I want to see what the entries of the grid are. So see out or debug. Well, we'll also to debug print the okay, let's see what the hell happened. Okay, so we saw that there should be a unique way to do this thing, and it's kind of like the bits are telling me which I'm already forgetting like what these numbers represent. So I should be applying to 3 places. Is it fxc? Oh, no. The fxm. No, it's definitely not fxc times m. Yeah. What is this n you're taking the mod of? N is 2 to the k. It's the size of the grid. I don't think that part is borked. Is it subtract? I don't think that should make a difference because all this is going to do is reflect things. I'll try it. Wait, what? How can it crash if I... Huh? But... Okay, yeah. I don't think that was the issue anyways. I didn't know that actually. I didn't know the percent operator gave you negative numbers at all. I thought it always returned something between 0 and n. Anyway, I don't think it matters because that just amounts to reflecting the polynomial, which is not the issue that is here. Did I compute the inverse correctly? Oh, this is... So I think this 5555 corresponds to like this 55552326. Wait, isn't this just the input grid? Wait, this is the input grid. The heck? That's not good. Wait, this is literally a translate of the input grid. How did that happen? Hey, they just translated the input grid. That's not what I want. Oh, wait, that was actually... I feel like all this does is reflect the... Okay, whatever. I mean, I'll... Do I actually have to be careful about... Like, I feel like all this does is reflect the polynomial, right? Or something? Like, I don't see why that should make a difference. Because... Oh! Okay, that's a good point. Okay, yeah, it's not equivalent to reflection. Okay, fine. But then in that case... Now what's the issue? It's supposed to be plus? Okay, wait. No, it's minus. It is minus. It's supposed to be plus? No, what? No, it is minus. Like, cause it's the next grid represents what's happening when you're multiplying. Does the off by 1 error in F matter? Which F1 off by 1 error? by 1. You think it's plus? Okay, well, I mean, neither of them are working, so, like... Okay, well, what am I doing? So I have the grid. I'm multiplying by... Also, how is it plus? It's, Fuck, you're right, it's plus. You're right, it's plus. But then, okay, I mean, it's also still not working. Where you copy next grid to grid and reset it. Huh? Wait, is this not correct? Does that... I mean, yeah, that doesn't... okay, I did something else wrong. Grid IJ... You are resetting the grid after each element of F. Is that not correct? Right, because I'm multiplying, like I start with G, and then this is represents multiplication by fxy, and then you multiply by f of x squared y squared. And the reset should occur at the end of the... Oh! I agree. This is... I see. Each element... Oh, God. I don't even know what version of C++ I'm using. What's my version of C++? Just do... Okay, just do... I don't know these things. Shit. Oh my God. That was a struggle. God, having that in the wrong loop was... Oh lord, that was just like, what is that? Okay. Another 3,500 volt. Oh my God. Oh, that was an experience. That actually took a lot less time than I thought it would. How long did that take us? That was like... between when we loaded the problem. Yeah, that's under 2 hours. Oh, that's not bad. Despite the very large number of nudges that were given. Okay. No, yeah, this is a good problem. I agree. I like this problem too. So did like the did the condition that n is a power of 2 matter that much? In the sense that I guess it would have been super annoying if like the order statement becomes weird if n is not a power of 2. Oh, right. Yeah. Then okay, yeah. Yeah, I agree. Where's the editorial for this? I guess. People who don't put backslashes. Wait, sorry, this is the wrong. What is this? Wait, this doesn't look like what we... Is this induction on K? Oh, that's interesting. Okay. Okay, I'm trying to read this. I think I agree with Twitch chat, which is that they're basically doing the Frobenius thing, but by induction on K without referencing the generating function. But I think this kind of thing should be discussed in terms of generating functions. Or, I don't know. I mean, obviously, if you don't know that kind of math, it's not going to work. But I feel like if you're comfortable with F2 adjoin XY, that feels like the right way to think about it or something. SMH Anton. Oh, is this... Yeah. No. Frobenius is good. Yeah. No. But also, like, this was a lot shorter. Like, when I was, like, writing the, when I was, like, working on the board, being like, okay, this is the algorithm, I'm gonna be like, oh god, this is gonna be so annoying to implement. But this is actually very short. Like, there's only one line that really... Like, there's a bunch of for loops, and then this is the line that does all the heavy lifting, and everything else is kind of boilerplate. Like, this is read input, the read input. Here's the multiply. This is all boilerplate, and then this is read the output, read the answer. So that ended up being a lot more gentle than I thought it would be. Also, this brace is in the wrong place. I have half a mind to resubmit to fix this indentation, but I don't think that's a good use of CodeForces server bandwidth. We'll fix it when we upload this. Okay, alright. Yeah. I only suggest banger problems. Yeah, no, that was a good suggestion. I concede. Yeah, okay. Well, if you're watching this on YouTube, thanks for tuning in. We're probably going to make some really clickbait thumbnail about the rating of this problem being 3500, because last time I did a 3500 problem, we put that in the thumbnail and it got a ton of clicks. So we might do that again. But yeah, thank you for tuning in. See you all next time.